Project 1.8 is called Build a Body. Now, Project 1.8 is going to build upon a lot of the skills you've already learned in the previous activities. And a project would be much more challenging and will take a lot longer time than the activities have taken in the past. So when you get to this point, please be willing to troubleshoot your problems with a partner, someone that you're collaborating with. It'll work a lot better for you. A couple of essential questions at the top. You've seen these before. It all connects together with the project. Here's a rubric you can look at. There's some organ system descriptions. Here's your AIA file that you need. Form, build a body peer feedback form. You're not probably going to use this, but it is there if you need to. Build a body app design requirements PDF. That's obviously going to be helpful because that's something that you're going to need to know how it's going to work. The design process. Here is the design process. And this is very similar to an engineering design process. You're going to define the problem, and they're going to show you in a little bit what that is. You're going to generate concepts or ideas on how you can solve the problem. You will design a solution in order to solve the problem. You're going to build and test, and it's going to take a lot of time to build and test. When you get to this part, you may have to go back up, change it, come back down, keep changing it, and going around and around. After you do build and test, you will evaluate the solution. Is it a valid solution? Does it work? Does it meet the requirements that I'm supposed to meet? If so, then you present your solution. Document all your project work in your PLTW Gateway notebook. You all know how to do that at this point. Define the problem. So they're going to walk you through these steps right down here. Review the following design brief. Here's what it looks like. So the client would be a life science teacher. Target consumers, middle school students. Here's the problem statement. The middle school life science teacher is describing the anatomy of the human body and wants an engaging and an interactive way for students to learn where the different body systems and organs are located. Here's your design statement. Design requirements or the criteria for what is expected. Before you present, you should be able to check these off. Now there are going to be some, include one of the following additional features. This is up to you. There's a bunch of really neat ideas on how to do this. You would know how to do all of these based on previous activities that we've already done. Here's some deliverables, and then here's some constraints. It has to be created in App Inventor, which that's the only one we've used. Here's your rubric link again if you need to. Design a solution. So this is the next step. Download this. Log in, you know how to do that. At this point, you want to have it connected to the tablet. You want to see what it's actually doing. You want to look at the code as well. Choose one of the following features to include in your app. Here's something you can do. Decreasing the score, very similar to activity 1.7. Include a timer. We did that in 1.7. Include a solution button. This would be a very simple idea. You click the button and it shows where all the organs are supposed to go. That deals with the XY, which we've looked at before. Display a description of the functionality of the organ system when a user clicks it. This might be a notifier. It could be a text string that scrolls up on the screen or it pops up on the screen. You're going to sketch a design plan. This could be something, if you're not very good at art, you can just draw it quickly in your notes if you want to. It's just going to help you figure out the layout for what it looks like. Now here is, I will open mine up here in just a second. So here's what it looks like in the beginning. Now I added in the score and the timer. I put in a reset, start, solution. I put those in there. Main things to be aware of in the beginning, if I click on the digestive system, it's going to show me the X, the Y coordinates. This will be important because on the black side of it, it shows you the initialized variables. So you can do initialize digestive system X is -2. The Y is 14. You can go to the different systems. So urinary system, X is 214, Y is 9. Now the nice thing about doing that up front, and I'll show you real quickly what that looks like. When you call, you don't have to put it in every single time. You've all done the timer before. One of them is dealing with dragging. So you're dragging the system, and then it's going to click into place based on what you do with the code. Controller layer, it shows you some questions that you're supposed to answer. Here's the chart. Build and test your solution. At this part, you should start building it. You should be able to drag the different systems around. So basically what you're going to do is you're going to drag, let's say, the brain on your tablet. You're going to set the code up on App Inventor. You're going to be able to drag with your tablet and connect it right there. Then it's going to lock into place. So this is where you're going to think about the brain enabled goes to false. Once this collides with this placement, it should connect together and it should be shut off. When the heart, or the respiratory system, connects to the correct location, the respiratory system placement, it should be enabled to false. Now if I hit the reset button, it should take it right back here to the original location. Now I've already shown you how to do the original location. If I had a solution button, if I click the solution button, these should go to their correct XY location. All right, a couple more things to look at here. I'm going to open that one back up. While that's loading, here we go. Controller layer, you're looking at your XY position. A big part of this app is understanding where they're located. So right here, what's the XY? Where's it supposed to go? The urinary system placement is right here. What is the XY there? They have to collide with, so you need one that is dragged. You also need one that deals with touch up, meaning like you let go. So otherwise, they're all going to connect together. Here's your debugging steps. Here's how you evaluate the solution. Here's when you present your solution. This is where you can present it to somebody else. Have them test it out before you present it to me. Conclusion questions, those are just something you write down in your notes. Now again, it needs to have something extra. So something extra could be, if I drag the brain here, it's not colliding with the correct location, it goes negative points. Also, if the brain collides with the correct location, it stays and turns off. If it collides with a different point, then it should automatically go back to the original location. And again, that's all based off of the original XY. Here's just a real quick look at dealing with the placements. What are the X's? What are the Y's? And so forth. You don't need to copy from here because you need to understand how it works. But that is what it looks like. You need to know where the X and the Y is. Then in your code, you're going to call it from here instead of typing in the numbers every single time. All right, best of luck.